name's Alana Hudson, and I'm a part of Challenge 2016. Today we'll be answering our first seminar video assignment questions, and I am in Calculus 1000. So for the first one, we'll be doing number 24, which asks for the domain and range of y equals tan to x minus pi. Again, it's y equals tan to x minus pi. So this is what the original graph looks like. You flip it around. It has a lot of different pieces in it. Clearly, just like the regular graph of tan, and also like the regular graph of tan, we have to restrict the domain to get its domain and range. So we will. Here we actually have the domain and range when we restrict it. So we restricted it, and so now the range, which is all the y, is negative infinity to positive infinity. And the domain here, it stops at negative pi over 4 to positive pi over 4. It doesn't include them because there is a vertical asymptote there, which is the dashed lines. And so, again, the range is negative infinity to infinity because the y's don't stop. They can be all real numbers. And the domain is negative pi over 4 to pi over 4. And of course, if you were writing it in interval notation, it looked like this. The next problem is number 79, and it asks for the domain and range, the graph, and of y equals sine inverse of sine x, and of y equals sine of sine inverse of x. Okay, so first we're going to look at one of the graphs. Let me position this. Okay, so the first graph you're seeing is the sine inverse of sine x. And so it kind of looks like we have some mountains here. The graph goes increasing, decreasing, increasing, decreasing, increasing, crosses through the middle, and of course we'd assume that if the number line were longer, it'd continue the exact same pattern. And for this reason, we can say the domain is negative infinity to positive infinity, or in other words, all real numbers. But the range, though, here is different. The range is negative pi over 2 to pi over 2. So if pi over 2 and negative pi over 2 were featured here, you just see that the graph never passed those. But you can kind of see it in respect to the 1.5 we have here. And this one's actually negative. It's not writing. Yeah, negative 1.5. So now we can look at the second graph, which is sine inverse of x. Now this graph looks totally different. We have a linear graph. It's only a line, and it passes through the center just like the last. And its domain, though, is from negative 1 to 1. As you can see, it doesn't go past the again, negative 1 or past the 1. And interestingly, the range is exactly the same. it doesn't go past the -1 to the 1. So the domain here is -1 to 1, and the range is -1 to 1. And if you're writing an interval notation, it'll look like this. It is including the 1, and so there are points at the end. But I guess the hugest difference we can say between the two of these graphs is that sine inverse of x is 1 to 1. And we'd ask why. Well, because this passed the vertical and horizontal line test. So in other words, if we were to draw a horizontal line through the graph, it only touches the graph once. So it passes the horizontal. And if we were to draw a vertical line through the graph, it only crosses it once. So it passes the vertical. So in other words, y equals x. And so sine inverse of x is 1 to 1. But if we were to go back to sine inverse of sine of x, does this one pass the vertical and horizontal to be 1 to 1? It doesn't. If we were to draw a horizontal line, it touches it 1, 2, 3, 4. And that's too many times. And if we were to draw a vertical, it only touches it once. And that's fine. But for a function to be y equals x, or 1 to 1 in other words, it has to pass both the vertical and horizontal. And so that's the hugest difference there. So that's the two graphs of y equals sine inverse of sine of x and y equals sine of sine inverse of x. And those are the two questions. Thank you.